Hey guys, welcome back to Weld.com. Today's episode 3 of welding symbols. So we're going to go ahead and put this one to bed. We're going to cover contours, tolerances, spacing, plug and slot welds, surfacing welds, and edge welds. After that, you should be well on your way to being able to read, understand, and interpret welding symbols. So let's go ahead and get started. We're going to talk about contours first. So we all know what this is. We have a 3/8 weld on the arrow side, so this weld would take place right here. Let's say we're using a process like shielded metal arc welding, right? We know that we're going to have a convex bead appearance, convex weld appearance. But here in my note section, I have a flat line, right? And then I have G for grinder. So right down here, I have, these are the different designations for the process that we're going to use to contour these welds out. So we have C for chipping, G for grinding, H for hammering, M for machining, P for planishing, R for rolling, and U for unspecified. So these are the different methods we can use to obtain our different shapes and profiles for our contour. So this one right here is flat. So we'll just cover these really quick. So we have flat, we have concaved, and we have convex. Okay, now if you can obtain these different shapes and profiles just by the welding process, typically you're not going to have a contoured shape in there. They're not going to require you to do any contouring. But let's say they want this ground with the grinder. We're going to grind this flush. So you put your weld in there, get it to the appropriate leg height, and then we're just going to go through with the grinder and contour that weld, basically taking that face off, making it flush. This could be for various reasons, part fit up, part alignment, different things like that. So just pay attention to that. That's what that letter stands for, and that's what that symbol right there. These are found in your supplementary table as well. Let's go ahead and take a look at this groove weld down here. So what's this telling us? We have back or backing weld. Okay, so this backing weld, we're going to put that in there. Let's just call that, we'll just say it's a, we did backing last time. Let's say that's a back weld. So what's that mean? We're gonna go ahead. That back weld will be put in after the fact. So we'll go ahead and fill this groove in. On the back, we're gonna grind that or gouge that back out, and then we'll put that back weld in there. So we now have our weld placement in here. Okay, so we have all these different layers in here, and it tells me that my back weld is gonna get machined flat. Okay, so we're gonna come in here and we're gonna machine that. Okay, probably with a mill surfacing machine, something of that nature, depending on what's at your disposal. And then this one right here, where we have that bevel on there, we filled that bevel in, that's going to go ahead and get chipped flat. So you'd come in there and you just chip that, and that's off the top. This is just two different examples, one with chipping, one with machining, just so you can kind of understand what's going on with that. That wouldn't be a typical application. They're probably just going to have you grind both sides or machine both sides. Most likely you're going to use the same method on both sides of that material. It's just an example. So let's go ahead and move on to different tolerances. Okay. All right, so let's go ahead and talk about tolerances. So as you know, with blueprints or shop drawings, you usually have tolerances listed out in your title block or maybe in the general notes section at the beginning of the prints. What they may not have is tolerances as far as weld size. So you're going to find that information in the tail of each welding symbol. So say for instance we have intermittent fillet welds, and they're uniform, they're not staggered, and they're 2-on-6, and we have a 1/4 inch weld. So I have a 1/4 inch weld side on each side, or a 1/4 inch weld size on each side. Spacing is going to be 2-inch welds every 6 inches. So as far as my segment length tolerance, I'm allowed to be plus 1/4 inch. So each one of these welds could be a 1/4 inch longer, and I'll still be within the appropriate dimensions. Can't be any less than that 2 inch. So I can have anywhere from 2 inches to 2 1/4 for each one of my weld sizes. Okay, that's going to apply to each one. Now let's talk about fillet weld size. So this is telling me right here, I'm on the other side now. I have a 3/8 weld on this T-joint. So I have a 3/8 tall fillet weld, so that means leg height, vertical and horizontal on this fillet weld. And my fillet weld size tolerance, I can be plus 1/8 inch to 0, right? Can't be any less than 3/8 inch, but I can go all the way up to a 1/2 inch if need be, okay? So that's pretty much tolerances. They're going to be listed out in the tail. Remember, the tail is where we're going to find special information or additional information that they don't have an appropriate symbol or supplementary symbol for. So that's where we're going to find that information, is in that tail. Let's go ahead. I mean, it's pretty self-explanatory. Now you've been exposed to it, always check your notes section. Sometimes inside the tail of the weld, they could refer you back to a specific detail that's on a different page. So they'll give you that page number in there and that detail number. You'll flip over there and you'll get additional information on this specific weldment. So now let's go ahead and talk about spacers. There's a lot of information going on in this symbol, but just like any other time, we're going to go ahead, we're going to break it down one piece at a time. So the first part that's probably throwing most of you off is this menagerie of information right here. So let's take care of this first. All this is, you guys have all seen a double V bevel. Okay, if I showed you that, you'd be like, okay, no problem. You know, I put a double bevel on each plate, we're good to go. All this is telling me is I'm going to have a spacer in between there. Same preparation. We're just putting a spacer in. So let's go ahead, we'll break this down one piece at a time, just like eating the elephant, right? So this tells me I have a 1/2 inch depth of preparation at 30 degrees on both sides, arrow side and other side. I have a 3/4 inch depth of penetration and a 1/2 inch root opening. So let's go ahead and put it all together. First thing we're going to do is bevel our plates out and then put our spacer in. So we bevel each plate 15 degrees, right, for that 30-degree included angle. All right, so what we're going to do now is we're going to put our spacer in. Okay, so it should be specified right here in the tail section. It tells us we're going to use SAE 1010 1/4 by 1/2 inch spacer. Okay, so the engineer has that spec. You know exactly what to order. Your shop foreman knows exactly what to order to put in there. You got traceability for when the CWI shows up and checks out your fit up before you start welding this thing out. He can verify that you have the exact spacer in there that you need. Right, so we have everything prepped. So this is going to be our 1/2 inch depth of penetration or depth of preparation. Remember, that's going to go from the top of the plate. Once we put our weld in here, we have our 3/4 depth of penetration. Same thing in this area. So we're good. That pretty much covers it. Just a quick recap, right? We have 1/2 inch depth of preparation. That's how we're going to prepare our plates. 30-degree angle. So each plate gets 15 degrees. 3/4 inch depth of penetration for our welding area. We've already set our root opening at a 1/2 inch because of our spacer that is spec'd out in the notes. You can do the same thing on a single bevel V. So just real quick, we'll throw this in here, put our spacer in there, but now we have a single bevel V. This is going to tell me that I only need to break one side and my spacer is going to go in here. Okay, very simple. Just look at the welding symbol as a whole and then just start breaking it down one piece at a time. Okay, we'll go ahead and we'll talk about consumable inserts real quick. Very similar to this whole setup. Nothing too fancy, nothing too complicated with it. Okay, so now we have a consumable insert. Very simple, right? We're going to go ahead, we have a V bevel, right? 1/4 inch opening, so that tells me that my class 1 insert is going to be 1/4 inch. So let's go ahead and prep this one out. This one's fairly simple. And then that insert is going to go right in between. We'll do a different color. Okay, now they also make these inserts for pipe. Okay, it's nothing more than a ring. So just make sure, order the correct class of insert that you're going to be using according to the notes in your tail. You order that. You have traceability for the inspector. He can verify this at fit up, and you should be good to go. So consumable inserts, very simple. You can think of that almost like a backing bar. And then if you had to remove this, once you were done, you'd have an R in there. Very similar to a backing bar, okay? It's just a different type of insert. That pretty much covers spacers and inserts. They're very simple. Let's go ahead and talk about plug welds. Plug welds usually occur on areas where you would have a lap joint and you would put a fillet weld in there. Well, let's say that we have some other parts that are going to interact with this and that weld's going to be in the way. So we can't have that weld here. So we're going to go ahead and put them on top, right in this area. So what we have right here is this is a standard welding symbol for plug welds. This number to the left, remember, that's usually the size of our weld. In this case, it's going to be a diameter. So we have a 3/4 inch diameter. 5 equal spaces. Now because it's in parentheses, this is going to tell me the number of spaces that I'm going to have. So I have 5 equal spaces. And then this number right here is going to tell me the distance apart. So you're going to have to figure that out on your own, where they're going to sit, equally, where you have 3-inch spacing on all your 3/4 inch holes, and then you're able to put 5 of them in there. Now there's one other thing that can occur, okay? If these holes are countersunk or counterbored, you're going to have that angle in there. Okay, so just like in our groove welds and things of that nature, we have our angle that's going to be just below our symbol. So what's that going to do for us? Okay, we're just going to have to change this to where we have that bevel going on here. And these will be usually machined, okay? You're not gonna do this with your torch. So now we have our 30-degree opening in here. We'll be able to set that in there and then fill that in accordingly. And you're just gonna fill this whole thing up. So now if you remember from episode 1, we have this dotted line in here. That just tells me it's a hidden line. So I wouldn't, if I had this, if I had a piece of material here, it has a hole or a slot in the top. If I turned it sideways and was looking at it this way, I wouldn't be able to see that. So they put that dotted line in there that tells me that that's actually occurring in the material that I can't see. But if I rotated it this way, you'd be able to see it. So this is what they call a side view. Okay, so that's all that dotted line is. Just signifying that that's a 30-degree pitch in here. Now they usually won't have your angle in here because it's already been stated up here. Okay. One other thing that they could have, let's say we have, let's say this material is 1/2 inch thick. Okay, up in this inside, okay, if there's nothing written here, you're going to fill this weld completely in. But let's say we have a 1/2 inch weld here and they only want 3/8 of fill. Okay, we're going to penetrate in there until we have 3/8 of fill. So you should have 1/8 of an inch weld, or 1/8 of an inch material between your material and your weld once you finish that off. So that's all that is the depth of fill, and it's going to be inside that plug symbol. So remember, right here we have our diameter, which is going to be our weld size, 30-degree preparation. We're going to have 5 equal spots, 3 inches apart, with a 3/8 depth of fill. Okay, that's pretty much all your plug welds in a nutshell. I mean, they're relatively simple once you look at it. Just like I said before, break everything down one step at a time and go through. And I usually sit back and I'll look at the symbol and contemplate and kind of mentally picture how I'm going to prepare everything on my head, maybe even draw it out and make sure it makes sense to you before you start drilling holes and all that good stuff. And then just make sure all your numbers are right. Lay your spacing and everything out, get all that set up, right? Slot welds are very similar, so we're going to move right into slot welds. All right, let's go ahead and talk about slot. Very similar to our plug weld in layout, right? The only difference is, if you notice now, instead of 1 dimension, I have 2, right? Because I have weld size and the pitch, right? So I have 2-inch long welds, 3 inches on center. This 3/4 inch right here is going to be the diameter or the width of that slot. Okay, so that's the 3/4 inch mark. We have a 45-degree preparation. 3 on center, we already covered that. 45-degree angle of preparation, that's going to go right in here. And like I said, this is for instructional purposes only. So don't go designing structural components and be like, oh, well, Weld.com said I can just use 45 degrees on this for a 1-inch plate to 3/4. Don't do that, right? Now, if the depth of fill is anything different other than flush or full, it's going to be listed in here. So let's say I have a 1-inch thick piece of material here, but they only want, I don't know, let's say 7/8 of fill depth, right? I'm going to make sure that once I'm done with this, I have about 1/8 of fill between the top of my weld and the top of this plate, okay? Very simple. Like I said, just take everything one step at a time. And that's pretty much all your slot welds. Again, this could be a lap joint or regular T-joint where you could put a fillet weld in here, but there may not be, there may be other intersecting parts where that weld's going to interfere. So instead of beveling the plate that's going to lay in here, we'll just weld the inside of that and we don't have to worry about it. So a lot of Bucket blades, you know, you're going to have slot welds on that or plug welds on that. You know, if you have to repair those, there's a bunch of different instances where these would take place. Okay. Okay, moving on to surfacing welds. If you've ever been a student in a weld school, you're probably very familiar and proficient with surfacing welds. Okay, I used to make my students do this all the time. You give them a flat piece of material and you just have them lay beads on a plate side by side, overlapping 50%. And what that's going to do is that's going to cause that material to get thicker and thicker. So it's actually a real world application. It's used a lot in surfacing, hard surfacing on bucket blades, dozer blades, anything like that, rock crushing equipment. They rebuild the surface. Same thing on a worn out shaft. If you have a shaft that's been worn out due to wear, they'll fill that back in. We'll talk about that here in a second. And they'll be able to machine that back down to its true size. So let's say we have a piece of 3/8 plate right here, and we need to put an 1/8 inch of surfacing on here. So this dimension right here tells me that's my height. Okay, whereas same thing with a fillet weld, that's going to tell me my leg height. This is going to tell me the bead height. So what I would do is I would just weld overlapping welds all the way across that plate from one side to the next. So while we're on the subject here, we'll talk a little bit about blueprints. We're going to draw what's called a cutting line or cutting plane. So I'm going to put a little A right here and an A right here. What this is going to tell me is that if I took this plate and I cut it directly right here and rotated this up, I would then get a side view of it. Okay, and I would know that because there would be another drawing next to it that's going to have that rectangle shape with hatching in here. And due to ANSI standards, each type of material is going to have a different type of hatching. So concrete has one different type of hatching. Aluminum, steel, everything's going to have a different type of pattern hatching. But what this is essentially going to show me is all my overlapping welds. So that's how they would lay in there, just like that. So what used to be a 3/8 wide plate, now we measure to the height of my crown, or that weld. I'm going to have a 1/2 inch thick plate. And then they can machine this down. It could be 5/8. You know, if they increase the size, they're going to machine it back down. So now I have a thicker piece of material with a much harder material on top than the base metal below. Same thing when we get into, let's say we have a shaft here, and the center of this shaft has been worn down, and I need to build that surface back up. Okay, it's just been wore out, it's been in use, and it's a lot cheaper to repair it than it is to replace it. So what I would do is look at my welding symbol, and this tells me we need one layer of circumferential weld, circumferential meaning all the way around the outside, 1/8 inch high, and then we need some axial weld, right, which is going to run perpendicular to that circumferential weld, 3/16. So the first ones we're going to do is our circumferential welds. We're going to make sure we have 1/8 inch bead height. I'd put this in a rotator if I had the luxury. So if you notice, the reason we're doing the circumferential weld first is because that's how it is listed on our print. So remember, we're going to take from the arrow, right, and we're going to work our way back. So this is step number 1, first step, and then step number 2. And if it went on and on, we'd have step 3, step 4. They could even tell you what type of welding rod to use in here if you're doing hard surfacing, or you have a specific composition of material. That information would be in your tail as well to tell you what type of electrode that you should be using in there, or process. I have some previous students that do this. They work at a recycling facility, and the parts that crush up the cars all the time, they're constantly getting resurfaced just because it's cheaper to repair it than it is to replace that entire shaft. So now we have our 1/8 inch, right? So if this is, let's say we have 4-inch material, or 4-inch outside diameter piece of material or shaft. What are we up to now? Not 4 1/8, right? We have 4 1/4 because we did 1/8 inch circumferential all the way around, okay? So we have to add that 1/8 inch on both sides. So we're out here, we're up to an additional 1/8. Up here, we're up to an additional 1/8. So overall, I've increased 1/4 of an inch. So now I'm up to 4 1/4. Okay, now we have to put 3/16 axial welds. So these axial welds are going to go lengthwise down the shaft. We're going to do the same thing. We're just going to keep building them up, 50% overlap. All the way around. So now we have an additional from there 3/16 and then an additional 3/16, right? So that gives us a total of 3/8. So we're at 4 1/4 here. All right, so now we're up to 4 5/8. We have a 1/4 inch plus 3/8 overall for the 3/16 and 3/16. So we're up to 4 5/8 now. Okay, and this can be used in a lot of applications to make repairs. There's also one instance where we can use that to fix poor preparation. I'm going to show you that next. But we'll just cover this one more time, just real quick overview. I have just a regular piece of steel, and I'm going to do some hard facing on there. So they'll list the electrode out here, the welding process. We're going to take this 3/8 plate. Once we're done, it's going to be a 1/2 inch thick because we put that 1/8 padding on top of that. And this is our section or cutting plane line. So this would be section A on here to tell me that that's the direction I'm looking at. I'm going to cut and look this way, so it's going to rotate up. If these arrows were pointing the opposite way, I would lift this section up. And a lot of times it's very important, depending on where it's cut, to what you're going to see if you looked down to the right or down to the left of that piece of material. Okay, getting back down to the shaft here, we have this piece overall, 8 inches total, but it's worn out in the middle. So we're going to put, our first step is 1/8 circumferential weld of surfacing welds. And then our next step is 3/16 padding of circumferential welds. And that's just going to expand my diameter basically twice that weld size once I'm done. Now they take it over to the machine shop. Machine shop, he chucks it up in his lathe. And he machines it back down to its original 4-inch diameter. And they're ready to rock and roll. So let's talk about one more instance where we would use surfacing welds. Okay, let's say I'm out on a job site, and a lot of you welders probably ran into this. Your fitter is having a bad day, right? And you're supposed to join two pieces together, and you're supposed to have 1/8 inch gap right here. I can't draw today. Couldn't draw yesterday, no excuse, right? So you're supposed to have 1/8 of an inch gap here. And the CWI comes out and he measures it and he's like, nope, what you actually have there is 1/4 of an inch. So they can get a hold of the engineer, him and the engineer can talk it out and what they can do. And I'm not by any means saying that this is the proper way to replace this or to repair this. This is just another instance where you could use surfacing welds. But once again, it needs to be signed off by an engineer. So now I have my 1/4 inch opening, and I go in there and I start running some surfacing welds. And I repair the edge of that material, and I'm back in, because of my poor artwork, we'll go ahead and say now we're hitting that 1/8 inch that we were supposed to be hitting from the beginning. And then you can clean that back up. Now you can go ahead and make your additional passes in there. Like I said, don't go out there and saying, well, this is how you repair it because I've seen it done on YouTube, so it's got to be right. If it's on the internet, it's got to be true, right? So that pretty much covers many instances where you'd run into surfacing welds. So remember, hard facing, repairing worn out materials, shafts, things like that, and then fixing piss poor fit up. So just a couple different examples of when that would be used. Okay, so we have our material here. We'll go ahead and say we need 1/8 inch weld size here. Again, that's going to be the depth of preparation on this one. So these are very simple. Okay, so if we had two pieces of material we're going to lap together and do an edge weld. It's another instance we could run this, say 3/16. Another application where we could run this method. Okay, and that would be 3/16 here. Okay, now let's say we got we want to weld here. So what are we going to do? So on the arrow side, we have our edge weld, we're going to go ahead and let's say we have a flare V in here as well. Okay, so we're just going to go ahead, fill that flared V in. All right, so another instance, we can combine 3 pieces of material together. Okay, that tells me I have to put an 1/8 inch weld in here. I'm going to join all 3 of these pieces of material together. So we have our edge weld up here, but then I want to put another weld down here. I could say put that flared V in there. And in the notes I could say typical. Okay, and that tells me wherever this situation occurs, that's how I'm going to take care of it. That's how I'm going to weld it. Another thing, I can have 2 arrows coming off the same symbol. So if you guys run into that situation, you can have either typical pointing to one area, or you can have 2 arrows pointing to those areas without typical written in there. So that pretty much covers edge welds. Edge, you know, just whenever you put 2 pieces of material together and you weld across that top edge or that seam in there, that's the symbol that you're going to see. Okay. All right, so let's do a quick review. Wow. I hope you got that on film. Oh, shit. We got it. All right, so let's do a review. So this chart right here, we can download this from Weld.com. You can go to our site, you can print these off however big you want. You can put them in your classroom, you can put them in your shop, you can put them in your conference room. You can print them off 8.5 by 11, that way you can carry it around in a handy little notebook. You couple this up with your quick reference guide we mentioned in episodes 1 and 2, and you guys will be untouchable. So let's just do a quick overview of what we talked about. This line right here is our reference line. We have the arrow line. Now these can be swapped back and forth, so the arrow can actually be on this side, tail over this way. It doesn't matter. We're always going to read this information left to right. It's never going to change. The only thing that'll pop over this way is the weld all the way around symbol and the field weld, because they meet where the reference line and the arrow line connect. So let's go ahead, we'll start talking over this side. The tail, we're going to find out specification, process, or other reference. So remember we talked about spacers and different things that we would find in this information, or this section of the tail. This is where that's going to be. So it could tell you SMAW, low hydrogen electrode. It could tell you what type of spacer you're going to use, what type of consumable insert. All kinds of information can be put in here that doesn't typically have a welding symbol or a supplementary symbol to cover that information. Right here we're going to have size or strength for certain welds. Over here we're going to have the depth of our groove. So that's the joint preparation that we're going to do. How far into that joint are we preparing it? Groove weld size. What is the depth of fill going to be? Okay. Finish designator. We have our contour symbol, so this would be flush. We have the angle, so whatever the included angle is going to be, and the root opening. Now this information could be put down on the bottom. Okay, if it's on the bottom, it's going to be reversed. Okay, you're going to have the root opening, then you're going to have your angle, then you're going to have your finish designator, and the contour symbol, and then finish designator. Either way. Get in here, this is where our welding symbol, or I'm sorry, this is where our weld symbol is going to be. Whether we have a fillet weld, a plug weld, a slot weld, seam weld, edge weld, any of those welds, that's going to be contained in this information. The length of our weld and the pitch or spacing is going to be over here. It's always going to be to the right of the welding symbol. That pretty much covers everything on this chart. Like I said, go ahead and download it. It's a great piece of reference material for, regardless of what type of welds you have to make. If you're reading prints and going off weld symbols all day, go ahead and download this. It's free. I mean, you could open up the website, take a picture of it with your phone, and store it in your photos. So this concludes part 3 of this series. We're still going to be talking about welding symbols from this point on. Every time we do an episode where we can incorporate welding symbols, we're going to go ahead and put them in there for you guys as a constant refresher. Make sure you like and subscribe to the channel. Follow us on Facebook and Instagram. And until next time, make every weld better than your last.